Good morning, everyone. I'm Manuel. This is Shanes and Lillian. And today we'll be presenting the Planck's Constant Experiment. Now, moving on to the diagrams. This is how we'll basically be setting up our experiment. So I'll let Shanes explain the details later on. But the concept here is that the energy of one electron will be converted to the energy of one photon. Looking at our variables, our independent variables will be the wavelength of the LED. So we pick an LED of a known wavelength, and we can confirm it using a spectroscope connected to a data logger, as shown in the diagram. Our dependent variable will be the voltage measured using the voltmeter, and our constant variables will be the ambient light, temperatures, and the other constant variables. It's important to do this in a dark room to clearly see the LED lights. Right.
Okay, so first you have to set up the experiments as shown. So as you can see over here, the ammeter, the potentiometer, the LED with different colors, the spectroscope connected to the data log. Then you have to slowly increase the voltage till it reaches the threshold voltage. So use the potentiometer over here to adjust the voltage till it reaches the threshold voltage. Then using the spectroscope connected to the data log, confirm the wavelength of the photon emitted. So as you can see over here, the spectroscope is connected to the data log. So use it to measure the wavelength, to find the wavelength of the LED. Yes. Then repeat for 4 to 6 different LEDs to get 6 different wavelengths. So you repeat the process above for 4 to 6 different wavelengths to get, yes, your accurate value. Then the precautions, you have to wear eye protection such as goggles so that you can prevent your eyes from being directly exposed to the LED. Then you have to repeat each reading for different LED and take their average value so that you can get an accurate result.
After the experiment, you can derive this formula from the experiment, and then you draw a table this way, and you add the values inside for each LED color inside, and then you draw a graph, and the graph is plotted by plotting the voltage over the inverse of lambda, so 1 over lambda, so that it will be a straight line through the origin, since there's no intercept over here. Because if there was an intercept, it would not be through the origin, but since there's no intercept, it will go to the origin, it will be a straight line. And then you calculate for the gradient, and then after that you take the gradient formula that you use here, and then you rearrange it so that you make H the subject, and then you find Planck constant because that's H. Yeah.
All right. Thank you.